Thank you. Hello, everyone. My students here, maybe made it to Montreal. All right. Do you guys remember when you first started coding? Do you remember like the feeling? You know, you had power over stuff. I mean, it was like zeros and ones, but still, you had power over it. That was a great feeling. That was an exciting feeling, at least for me. I guess it was 1994. Back then, if you're curious enough to know anything about the web, well, you were a webmaster. That's how we used to be called. And so, I was a master of the web. It's really my curiosity that landed me that first gig. I had no clue what I was doing, really. And but nobody else did, so good times. Of course, over time, I managed to learn HTML and then CSS, and then that clunky new language called JavaScript. Might have heard of that. And even though HTML and CSS and JavaScript were super basic back then, to this day, I still remember the original feeling brought on by creating something out of nothing with just a little bit of code. I bet you do too. That's an awesome feeling. Now, obviously, over time, excitement kind of waned out. And, you know, the web kind of became a business. And, well, at least for me, the excitement faded away a bit. And the cool kids started using Flash, so I started doing that too. And JavaScript pretty much entered this gestation period for like many years. Pretty much the only thing that happened was Ajax, and that was it. But then, something happened. Over the last few years, it sort of brought the excitement back. And in particular, I became very enthusiastic about the prospect that those technologies that I knew so well could be used not only like to push pixels on the screen, but to actually push real things in real life. How did that happen? I don't know. It's amazing. So, my goal today, if there is one, is to show you guys how easy, really, how easy it is for you to leverage your existing knowledge of the web platform to interact with the real physical, tangible world. The time has come to break out of that box, get rid of the security sandbox of the browser and all that. And so my promise is this. At the end of this talk, you will know enough to start using your digital world programming skills to interact with the good old analog world. Let's see if we can do that. In other words, it's time to level up. Now, if you stick around till the end, get a little setup there, you'll be able to witness or participate in something us geeks really dig, and that is a physical challenge, right? Right. So, I mean, each and every one of us, I'm sure, loves a physical challenge, especially if it involves an Arduino. So stick around, and I'll do a big reveal there at the end. All right, before we dive right in, let me thank all of you. I'm super psyched to be here in front of such a respectable audience. I've been a long-time attendee to the FITC, and so let me thank Sean and his team for making it happen, and of course, let me thank all of you guys for being here. All right, now, enough sucking up. During this talk, I'll be using this expression, physical computing. And it might not be as buzzworthy as, I don't know, big data or microservices or whatever. But it does have the distinct advantage of really describing what I'll be talking about today. So what is physical computing? You might think, and I wouldn't blame you, that this talk is about the Internet of Things. That's the big thing now, since a few years at least. We've heard so much about that. To be honest, I don't really know what that is, and I'm not sure the vendors know either, but hey, let's ride the wave. I mean, to me, like, I don't know, synergy or frictionless design or the cloud, or I heard, what was it? Empathy was the keyword this year. I have no idea. But one thing is for sure is that physical computing is not only about that. It's not only about the Internet of Things. So, while we're on a buzzword spree, is it about interactive installations? Or perhaps wearables and hearables and embeddables and ingestibles and all those-ables? Is it about robotics and mechatronics? Is it about all those kinds of interfaces we have around now? Is it about interactive or tangible medias or augmented or virtual or artificial realities? Many, many realities these days. It's confusing. Well, the answer is yeah, it's about all that. And the reason I'm sticking to that very, very broad term or expression is because really you'll be able to dabble in all of that using what you pretty much already know. My students have this website which they really like when it comes to doing research, and it's called Wikipedia. You might have heard of it. And this is Wikipedia about physical computing. So basically, Wikipedia says that physical computing, in the broadest sense, means building interactive physical systems by the use of software, hardware, that can sense and respond to the analog world. So the keywords are this: software, hardware, sense, and respond. This is physical computing. 4 words, this is physical computing. Of course, this is in relation to the physical world, the real world. But that's basically what it is. All right, let's get a bit more concrete here. Let's say you want to build a robot. Might not be a killer robot, but hey, a robot. Is this physical computing? Well, you're most likely going to need hardware, obviously, and you're most likely going to drive that hardware through software. So 2 keywords there. Perhaps you want to give your robot some sensing capabilities, like a rangefinder, so it doesn't bump into walls and stuff. So there you go, sense. And it's probably going to respond. It's going to, I don't know, back up if it moves, if it bumps into a wall, or go around it, go around the objects and such. So yeah, this is pretty much physical computing for you. Can you do that using the web platform? Well, yeah, you can actually. There's this great library. Actually, there are many libraries. I highly recommend you check this one out. We'll use it later. All right. Let's say you want to automate your house. Perhaps you want it to react to the outside temperature, adjust I don't know, the air conditioning or whatever. So it's going to sense its environment. It's going to respond, perhaps using your Nest thermostat or your Philips Hue light bulb or whatever. And yeah, this is physical computing. Can you do that in JavaScript? Well, yeah, there's a library for that too. How about art? Let's say you want to build this, this interactive art piece that reacts to the people that are in front of it. And you want to use, computer vision for that. Can you use JavaScript and the web platform to do that? Well, yeah. There's a port of OpenCV, the go-to computer vision library that can help you with that. So basically, each and every one of you out here today can find examples that would apply to your clients, to your projects, whether they'd be in marketing, and sales, and storytelling, and engineering, and live events, museums, whatever. I'm sure you can all use that. So, if you dare, that's the key here, you have a whole new area of expertise right at your fingertip. You're only missing a few pieces, which I'll tell you about in a minute. You just need a bit of curiosity. The same curiosity I had when I looked up this World Wide Web thing a long time ago. Jeez, I'm old. And the best thing, if you've seen other conferences earlier, is that this is in high demand. You might have seen the talk from the Leviathan guy. I mean, they're looking for people that actually know that. Of course, I'm not saying that will be easy or quick. It's a process, but you can definitely get started with the knowledge you already have. If you don't want to do it for business reasons, just do it for fun. I mean, building a robot with HTML, CSS, and JavaScript, that's pretty cool. That's pretty damn cool. All right. So, in short, the web platform and physical computing, they're a great match. They love each other, really. I mean, not that long ago, if you wanted to do any of that, you had to have quite a bit of money. You have to know compiled languages and embedded programming and shift registers and all that kind of shit. But now, you've got those high-level languages, one of which you know, JS. And you've got those high-level components, like ready-made components, that pretty much abstract away the whole electronic complications. So just a bit of curiosity. And perhaps a tiny bit of money, really, just a tiny bit of money. So, web developers, please meet the physical world. All right, how do we do that? 4 things. 1, 2, 3, 4. This is what you'll need if you want to get started. Number 3. I'm guessing you already have that, right? I'm hoping. You did read the title of the talk, right? So I'm guessing I'm talking to web developers mostly here. So if you know about these, well, you're off to a great start. I mean, JavaScript has been touted as the new C. It's the lingua franca of programming, and is arguably the most popular programming language in the world. We could have a discussion about that later, but you see my point. So if you know those, you're off to a great start. Now, that's not quite enough, right? How do I talk to drones and motors and lights and such? Well, you'll need something that'll let you bridge the gap between your usual environment, which is this guy here, and this here. So, what do we use for that? There are about a gazillion possibilities right now. This is crazy. But, I mean, this guy, it's been around a long time, and it's probably the easiest way to get started. Again, there are many other possibilities. The Arduino. It's been around for more than 10 years. It'll let you access external devices connected to it. So, for less than $100, and I mean Canadian bucks, you'll get a genuine Arduino plus sensors and actuators and everything you need to get started. So sensors, stuff that go from the world into the computer. Actuators, the other way around. So a sensor could tell you what the temperature is, the light level, or whatever. And an actuator, well, it enables you to control the world. So basically, it could be lighting, it could be a motor. You get the picture. Okay, so how do we talk? How do these two guys talk? There's this protocol called Fermata. Fermata can be installed on various devices, including the Arduino, and it enables basically a software bridge, between environments such as the web platform or others, and hardware devices. So you install Fermata, it takes about 2 minutes, and then you're done. This is the only time you'll have to fire up the Arduino IDE. You just upload a sketch, boom, on the machine, and you're done. You forget about this. Even if you power it off, it'll still be there next time you power it on. So Fermata is there, enables you to talk to the web platform. And the best way to do that, well, it's to use that library I just talked about, called Johnny 5. Who here remembers Johnny 5? Oh, yeah, this guy right here. 1986, I think. And I just read that Short Circuit 2 was actually shot here in Toronto. So I read about that, doing serious research, right? So I guess that's cool. All right, so J5 is a robotics library. However, what is robotics? It pretty much means gathering info from the world, processing that, and doing something with it. And that's really physical computing, right? This is the exact same thing that we will need. So for us, it'll be our physical computing library. Now, there's a catch. Johnny 5 is actually a Node.js library. It's not a front-end JavaScript library. So how many of you here have used Node.js? Oh, that's quite a bit. Good. Well, for you guys, nice walk in the park. You're right at home. If you haven't used Node, just think of it as JavaScript, but outside the browser. So you don't get a DOM, you don't get CSS and things like that, but it's still JavaScript. It's just that it runs outside the browser. It used to be mostly for developing server-side applications, sort of a replacement to ASP and PHP and such. But now it's really became this own, I mean, it's really a full development environment in which you can use JavaScript. And even if you haven't used Node, switching is going to be easy if you're a front-end developer. Of course, you might still think that not having the DOM and your canvas and your WebGL and your CSS transforms and all the cool stuff is kind of a problem, and I agree, because there's quite a bit of cool stuff that we can do in the browser with those front-end libraries. So we're still missing a piece here, and this piece is this guy. It used to be called Node WebKit. They changed it for something that looks shorter, that's actually longer to pronounce, nw.js. So I'm just going to call it New.js. I think it's cooler anyway. So New.js. What does that do? Basically, it allows you to use HTML, CSS, and JavaScript to build native, well, desktop applications. Let's call them desktop. They're close to native, maybe not actually native, but desktop applications for Mac, Linux, and Windows. That's cool. There are actually many frameworks that let you do that. What's even cooler is that this guy will also grant you access to the Node environment. So having access to the Node environment means that you have access to stuff outside the browser. You can read on disk, you can write to disk, you can access external devices and such. So this combination is pretty powerful. Anything that you can do in Chrome, plus anything that you can do in Node, you can do in New.js. That's pretty powerful. Pretty amazing, actually. So these four technologies together, I believe, make a very good, albeit new, physical computing framework or environment. And so I figured I'd give him a name. John, right? That's kind of cool. I've read on, what's that like sketchy site that tells you about words, Urban something dictionary? I don't know. They said on there that John is in Philadelphia. They actually use that to make, like, you just pretty much means anything and everything. I don't know if somebody's from Philly here can confirm that. But I thought it was pretty fitting, because this is really what we can do. We can pretty much do anything and everything with that. So, hey, that's a John toolchain. Boom, starting today. All right. Demo time. So, I brought a few things here. I have a code demo, because I want to show you actually how easy, for real, it is to do that kind of stuff. So first code demo, and then another demo, which I'm completely overhyping with my little curtain setup there. But hey, stick around anyway. So let's start with the code demo. So the first demo is very typical of the way you would get data in. Basically, you'd have a sensor. In our case, we're going to use a touch sensor. So basically, those little figure 8 holes, you can hook up like alligator clips there, and pretty much snap them to anything that conducts electricity. Then the data goes to the Arduino. What's nice about this is that there's no soldering, no electronics really that are involved. You just snap it on top. We call this a shield. And then from the Arduino to the computer via USB. And then you can use Fermata to talk to, well, Johnny5 can use Fermata to talk to the Arduino. And we're all doing that in the Node.js environment. Obviously, you could use a distance sensor, or you could use a motion sensor, or you could use whatever sensor. It's all the same principle. We'll be using a touch sensor. All right. First thing you need to do, when you want to create an application with Node.js, you need a package.json file. So those Node developers who raise their hands, well, you know about that already. So that's kind of easy for you guys. For those who don't know, it's just a JSON file with a few instructions in it that are meant to sort of set up the Node.js environment. So basically, this is like a super simple version, but you tell it which page to open first, index.html in that case, and what size window you want. Of course, there are many more options there, but for now, this is going to be plenty. So you create a folder, put that file in there, and you almost have an application. We'll see later that we need our index.html page, but that's pretty much it. Of course, in our case, we'll need to install Johnny5. So if some of you haven't used the command line, it might be a bit daunting at first. It's really quite easy, though. Just look up a tutorial on YouTube or something. So you fire up your terminal or your command prompt or your PowerShell, or I hear that Windows is getting bashed now, sometime soon. So anyway, I'm on Mac, so I think it's not there yet. I think we still have a few more weeks to be like better than Windows. But anyway. So what you do is basically this. When you install Node, it's just a regular installer, but when you install it, you get this command line tool called npm. So if you've used Node, you already know this whole part. And you say npm space install, and then the name of the module you want to install. And if you add -- save, what it's going to do, it's going to simply add that module as a dependency, meaning, well, to run that project, you need that module. So it should give you something like this. So you see at the bottom there, it did modify the JSON file to add this dependency. So that was rather easy, really. Just learn to use the command line. So that's kind of easy too. Now, this is the quirky part. There's a little problem with Node.js and the standard input. Doesn't quite work right. There's an issue anyway. So I created this little module just to make it easy for my students to get past that hurdle. I invite you to use it. It's actually not even my code. It's from Rick Waldron's code, who's actually the creator of Johnny5. I just put it into a module so it could be easier. So basically, you need to install that to fix that little issue. It's like 20 lines of code. Just don't worry. Just install it, and we'll use it later. So same thing, npm space install, and then nwjs whatever, and save. And then you've got 2 dependencies, and that's it. Our environment is set. Now, of course, we need an HTML page. So for my little demo here, I've got a body tag with 5 divs. They're colored divs. You'll see them on screen. They'll light up. And I'm using this library called tone.js, which is an amazing audio music DSP library. I encourage you to look it up. And basically, that's it. Of course, we then need to write a bit of code ourselves. This is still required. And this would be the code that I'm using today for the demo I'll do in a second. So, first line, you call up that nwjs.j5 fix, abracadabra, you're done. All right, after that, if you're a Node.js developer, you might have noticed that you don't use require. You would use nw.require. This is Node.js that sorts of imposes that. But that's pretty much the only thing you need to remember. So that shouldn't be an issue. Now, the real stuff happens below. We require. So meaning, for those who haven't used Node, it simply means you import. You will use that module. It's all it means. So you require Johnny5, put that in a variable. Oftentimes you'll see examples, they call it the variable 5. And then once you have that, you can create a board object. So basically, the board object represents your Arduino board or whatever other board you decided to buy, because like I said, there are many of them. And in true event-driven fashion, when the board is ready, it's going to trigger a ready event. And we can listen for that, and then do our stuff. So what we do is actually, in this case, create a keypad object. The reason it's called keypad is really because this touch sensor I showed you earlier is actually based off of a keypad, like the one you would find beside a door to enter your key code or something. They basically ripped out the buttons and made them into those little figure-8 holes. So in terms of the Johnny5 library, we just use the keypad object. And specify the module, MPR, blah, blah, blah. That's the module of the one I bought. There are other ones, obviously. So you create a keypad object, and you will listen to press and releases. That's easy enough. Of course, since I wanted to play some sounds, I also created a synth object. So this synth object is a one-liner, really. You could create a whole synthesizer with one line of code, thanks to tone.js. So tone.polysynth.toMaster, basically you create the synthesizer and you send its output to the master. That's quite easy. And then I have a notes array. Those are simply the notes that will be playing when I touch the different triggers. So touching the triggers, like I said, will fire up the press event. Releasing will fire up the release event. So when somebody presses one of the triggers, what it does is trigger that function, and then in the data.which, actually it's an array, you will find all the triggers that are being touched at that point, because there could be more than one. And so I play the notes, synth.triggerAttack simply plays the notes. And then I'm using a bit of dumb code there to add a class to my divs so they just light up. And on release, I do the opposite, really. I remove that code, but it's really, I stop the sound from playing, and I hide the divs. Easy enough so far? Yeah? Pretty sure it is for you guys. All right, shall we try it? And this is where it usually breaks down. Okay, so I'm just going to move this here. Those are my two demos. So we're trying this one. Oops, it's over here. Let me move it as well. It's this guy here. All right. So let's take that. Is this actually? Yep. Okay. So that's the little board. Whoops, right here. I've hooked up some wires with the alligator clips. Oh, yeah, it works. All right, cool. Okay, all good. So I said that those touch sensors worked with anything that's like conductive, electrically conductive. So you could hook them up to metals and stuff like that. But you know what? Turns out water is conductive. Actually, water is not, but the minerals in the water are. So this is not distilled water, is it? Let's hope not, because I need the minerals. So let's put a little water here. I figured if you're going to do a demo, it might be exciting to mix water and electricity, right? So don't do this at home. You might start a fire, but then again, you would have water to put it out. So it might be okay. I don't know. Okay, so I'm going to drop this first one here in the water. Okay. As soon as I touch it, I kind of influence the result myself. So this little guy here, third one should go, oops, in the third. Fourth one here, and then this one here. Oh no. I guess this one's no good. All right, I'll do the last one manually then. Okay, let's try it out. So, you might recognize this. Oh, well. Something like that. Faulty wires. This is something you'll have to get used to if you start delving into the physical computing world. It's a whole new set of issues and problems, but it's fun. You get to play with water and electricity. Actually, I'm going to unplug that. You know what? I'm going to move this. Okay. I don't want to screw up the other demo. So let's clean up a bit. All right. There we are. So that was easy, right? I had, what, 20, 25 lines of code there? Most of it is super simple stuff. Now, the question was, after this demo, what could I possibly do to excite this geek crowd here? So I thought about that, and like I said, I figured, well, how about a strongman challenge? And then yesterday, I don't know if he's in the room, I saw this guy, like big like this. I'm just hoping he's not here, because really, he's going to break my thing if he tries it out. I don't think he's here. So I will probably need a few volunteers, but maybe not that guy. I mean, I love you, man, but really, you're going to break this. So I figured, yeah, why not try a strongman challenge? And so, without further ado, let me switch to this. I give you Forso Max. Ta ta ta. Ooh. All right. This is a silly project that we built with my colleagues Ben and Chris. I believe Chris is here today. He's right there. So he's the guy responsible for that logo. You might want to let that sink in a bit. He did that. But then again, it is quite fitting. We've added a little accessory, especially for the talk today. And I guess we're ready. So would anybody like to try it out? Yeah, please come. I'm going to quit this. And I'm going to start the application, which is this guy here. Actually, I'm going to switch to this wire. So you're not too strong, are you? Yeah? Okay, come on stage. If you feel like it's going to break, stop. And I'll make you the instant winner. I'll be grateful. Okay, so I think we're good. And let's do this so we can see. Hold on. Okay, so let's start this thing. Here we are. So basically, in all honesty, this demo is the exact same one as the previous demo. Really. It's got a sensor, which is right over here. It's called a load sensor. But it could have been a temperature sensor. It could have been a distance sensor. It could have been a touch sensor. It's really the same chain. It's really not any fancier or anything like that. Can I put, oops, oh, wrong screen. Oh, crap. Hold on. going to put it on the right screen here. There we are. Okay, Forso Max. So can I put a nickname for you?
Sure. Leia,
L-E-I-A?
No, just
L-E-A? Leia. Okay, let's do that. So Leia. All right. So what you want to do, you can move the chair just in front. You want to go like this, grab that, leave your elbow on the table, and see if it works. Yeah. And it's, no, stop. It's not working at all. Hold on. Physical computing is always fun. This is it, right? Yeah, connected. This guy goes here, connected. Oh, come on. Let's try that one more time. Let's check a few seconds. Ah, crap. It was all full screen and working well, and then, boom, wrong screen, not working. Okay, so Leia, please make it work. Is it working now? Okay, I think it is. All right, I made you super powerful there. So I'm going to quit and start one last time. No full screen, move off the screen, go there. Here we are. Okay, so type in the box. Here you go. So I think this should work now. Oh, really? I just tried it. It was working. How is that possible? Oh, Jesus Christ. What did I do? I didn't do anything. Yeah, I know. It's always the case. Let me just shut it, plug it back in. So, regular troubleshooting. Unplug, replug, restart, whole thing. Let's pray now. Come on, demo gods. Leia, yeah. Okay. Is it? Okay, I think you can go now. Okay, go ahead. Try to beat what I just did. All right, go ahead. Let's share up. Go, Leia. Oh, is it?
no.
It's not moving at all?
No.
Maybe it's just help her out a bit. Come on, pull. Come on. Oh, come on. Really? You saw the needle move, right? There you go. Is it just a question of, really pulling harder? Oh, man, no. This thing was broken. Okay, so, well, thanks a lot, Leia! Woo! All right. I'll totally fake this then. The load sensor is here. When usually you just do like this, it pretty much is quite easy to squeeze. But the thing is, this is metal and it's been welded, and usually it works, but in that case it doesn't. But you would just pull it, and then anyway, you get the picture. But basically, this little load sensor here is what you'd find in bathroom scales. So basically, it detects how much it bends, really. And so you can use it for pull or push kind of sensing. And it just works really, really good when it does. Just to be absolutely clear, let me go here. This is actually, sorry for the French there. Where's my, it's here, over here. Let me move it over. So you recognize that, right? So this is actually my Chrome debugger. So this is really, it looks like an application. It's got buttons, and you can set menu. They're on my screen here, but I'm telling you, you can use menus. And it's really just a web kind of app. But the cool thing is, and we saw that earlier, is that you can actually use DOM JavaScript, like document object model JavaScript, alongside those node modules. Like just one line and then the other line, two different environments completely. This is quite amazing. So you have everything that you can do in Chrome, actually in Chromium, which is the source seed version to Chrome that's used in NW.js, and everything that you can do in Node.js, including all the third-party modules. It's a pretty amazing environment. Let me get back here. So, load sensor, very minute changes in electrical current. So you need an amplifier. Obviously, I used to be, well, I still sort of am a web developer. At least I'm teaching that. So I don't know nothing really about electronics. Well, I picked up some of it along the way, and you'll do too. Don't worry about that. But at first, instead of like trying to build my own electronics amplifier and stuff like that, well, you just go online and buy the Shield or the Breakout, and you're done. If you're a web developer, it'll cost you $20 more and quite a bit less trouble. So that's the whole point here. High-level languages and ready-made components. You can start with that, and once you're done, or once you've been used to working with those things, basically you can move ahead to discovering other areas, such as soldering, such as electricity, and so on, but you can easily get started without any of that. But most likely, you'll need that at one point. All right. I guess that's pretty much it. You can find the deck at this address. If you're into that kind of thing, look up TangibleJS.com. It's like a hobby site for me. It's not even a company or anything. It's just where I put up tutorials and stuff like that for you guys to enjoy. So look it up, and if you want to talk later, please come by and we'll discuss. Thank you.